Okay, good evening. Thank you for joining this interactive session on the course Fundamentals of Operations Research. So I understand that there are 5 people who are there listening, and we also have a set of questions which our TA Srinivasan will read, and I will try to answer them as we move along. So we'll first do you can also, meanwhile, start typing if you have some specific queries. We'll first look at those questions that he has, after which we will come back to these queries. Okay.
I would request sir to explain the bin packing problem.
Okay. The bin packing problem was introduced in the formulation part. Bin packing problem is a binary integer programming problem. So variables take binary values, 0 or 1. Therefore, I included it only in the formulation part where we formulate the problem. So solving the binary thing is not done by linear programming. It is done by 0-1 IP. Therefore, I think I have also demonstrated the solution in the 8th module, and I have shown an example of how to solve it and how to use Microsoft Excel to define binary variables and solve the corresponding problem. So it won't figure in the intermediate modules. So hand solution of bin packing is not included in your portion, as the case may be. I think there is a related query which talks about because module 8 is about using Microsoft Excel to solve. So there was a related query which said, are we going to solve problems like that in the exam? Which means, would you give us access to Microsoft Excel and so on? So the answer to that is, we are not going to ask you to solve problems using Microsoft Excel in the exam. So you can take it that the exam portion, if you approach this course from the point of view of the exam, then your exam portion is only 7 modules. If you approach this course from the point of view of learning, which includes the exam, then all 8, which means the 8th module is only meant to familiarize you with how to use Excel. That is not for testing purpose in the exam. So that I have clarified now. I think the TAs have also clarified it otherwise, that module 8 is only for learning purpose and not for the exam. So coming back to bin packing, as I said, was introduced to show binary integer programming formulation. It's a very interesting problem which is well researched, both from the operations research angle as well as from the computer science angle. I think I've explained the problem. So given some items are called lengths, Lengths, and you have bins of equal size, and the size of the bin is known, how do I minimize the number of bins so that I can pack these items or lengths into the bin? It is called one-dimensional because if a bin size is, let us say, 50, and I am packing a 20 and a 10 and a 10 and a 10, so which means when I put a 20 and a 10 and a 10 and a 10 into the bin of length or size 50, it means these 4 things will use up the entire size or length of the bin. So if you are physically imagining, it is like putting something into a bag, but it is putting one above the other into the bag. So irrespective of the order in which you put, the size or the height of the bag will be the same, but you put one over the above. That's called a one-dimensional packing. So the problem is about that. The problem is about, is there a way to open that particular module 1 slide where I have done bin packing?
Check.
Okay, let us not have that. I also at the moment don't have my PPT with me, but let me explain it as it is. So what you do there is, if let's assume for the sake of understanding that there are 10 lengths, 10 individual lengths, and there are bags. The objective is to minimize the number of bins or the number of bags such that all of them can be packed. So if you take away the minimization part, it is about putting these lengths into bags. So if there is no restriction, and if I'm not minimizing the number of bags or bins, I'm using the words interchangeably. If there are 10 lengths that can be put, I can take 10 bins, put one in each, and say that I can pack them with 10 bins. But that is not what we want to do. We want to minimize. Therefore, we start the formulation by saying that the maximum number of bins I require is 10. I don't need 11 bins to pack 10 items. So with 10 bins, I can pack 10 items. Therefore, we assume that we will have 10 bins and start the formulation. Or we assume that we will have maximum of 10 bins and start the formulation by saying yj equal to 1 if bin j is chosen and yj is equal to 0 if bin j is not chosen. Then we define an xij equal to 1. Yeah, I think he is able to get us that slide. The problem that I have used talks about how many lengths?
Maximum of 8 groups are possible.
So there are 8 lengths I have given. So I'm using the terms like length, group, all these interchangeably. So there are 8 lengths. If you see that slide carefully, it says the lengths are 8, 6, 28, 17, 24, 7, 21. So there are 7 or 8. 8. So 8, 6, 9, 28, 17, 24, 7, and 21. And the size of the bin is 45. So if you see the formulation, I'll just go through that slide. Assuming a maximum of 8 bins or 8 groups, yj equal to 1 if group j is formed, and xij is 1 if the number goes to the group. So next slide. So what we have to do is this. If I take one of the numbers, in this case 8 or 6 or 9, or any one of the lengths, it can go to only one bin or it can go to only one group. Therefore, you have a constraint x11 plus x12 up to x18 is equal to 1, which means it can go to only one group, which is written as sigma xij equal to 1 in the normal notation. The next constraint will be that if I take a group or if I take a bin, whatever I put into that group or bin, there are two things. It should be less than 45. I cannot put lengths that add up to more than 45 in a bin. So the constraint could have been written as 8x11 plus 6x12 plus 9x, etc. less than equal to 45. But I have written it as less than equal to 45 into y1. I have written 45 into y1 because I can put things into a group or I can put things into a bin only if I choose that bin. So this 45 becomes available to me only when y1 is equal to 1. When y1 is equal to 0, which means I'm not choosing the first bin or the first group, then that 45 is not available to me. Therefore, that constraint will be less than equal to 45 into y1. If I had not written 45 into y1 and if I had written only 45, then I have to add another constraint which will say xij less than equal to yj, which means only when I choose the group or the bin, I can put items into the group or the bin. So this way the formulation is actually over, but then I have to minimize the number of, what is the other one, Ratu?
It is a generalization of this constraint.
It's a generalization of the constraint where sigma Li xij or whatever is the number is less than equal to b into yj, where b is the bin length and yj is the variable. The objective now is to minimize the number of bins that are used. So the objective will be to minimize sigma yj. That is the bin packing formulation. I hope the person who asked that question is listening. And if you have a reaction, please type something so that they can read what you have typed and they can get back to me. Yes.
Sir, can please tell me about the exam pattern, because we don't know whether we'll get time to do all the sums within the 3 hours.
The exam will have a few multiple choice questions. It will have a few true or false questions, and I expect that these don't take too much time. You will have some very short answer questions, and you will have few big answer questions. Most questions would resemble what you have done in the assignments and so on. If at all there is, one or two will be slightly different. I think it is possible to do whatever is being asked in 3 hours. I think it is possible to do. And I think based on past performances, I think people have been, at least a few have been able to get about 90% marks and all that, if my memory serves right. So I don't expect that to be a major issue, but certainly what is required is taking the assignment seriously. And if you can, pick up another OR book, any OR book, and try to work out some problems and see whether you are able to get the answers which are given at the end of the book. Because if you map the content of this 8-week course versus any OR book, you will see the first few chapters of the OR book will have formulation, solution, duality, transportation, assignment. So largely the first 5 chapters of any OR book is what I have given as content of this course. So please do that in your own interest. That will help you quite a bit.
There is a doubt in module 2, assignment 2, 5th question. The question is on maximize 7x1 plus 6x2 plus 4x3 subject to two constraints, x1 plus x2 plus x3 less than or equal to 5, 2x1 plus x2 plus 3x3 less than or equal to 10. They are asking, the question was on the number of basic solutions. There is a doubt on how it is calculated.
So the problem has 3 decision variables and 2 constraints. So both the constraints are less than or equal to type. Therefore, you will add a positive slack. So you will add 1 slack variable for each constraint. And therefore, after you add the slack variables and convert it to an equation, you will have 5 variables and 2 constraints. So 5 variables, which has 3 decision variables and 2 slack variables and 2 constraints. But when you do the algebraic method, once you start solving, you are not going to qualify a variable as either decision or slack. A variable is a variable. So there are 5 variables and 2 constraints. The 2 constraints necessitate that you have 2 basic variables. The number of basic variables is always equal to the number of constraints. So 2 variables are basic and 3 are non-basic. So the 2 basic variables out of 5 variables can be chosen in phi c 2 ways, which is also equal to phi c 3, just as the 3 non-basic variables can be chosen in phi c 3 ways. So the 2 basic variables can be chosen in phi c 2 ways. Phi c 2 is 10. So the 10 choices, if you may call them combinations, would be x1, x2, x1, x3, x1, x4, x1, x5, x2, x3, x2, x4, x2, x5, x3, x4, x3, x5, and x4, x5. These are the 10 ways by which you choose 2 out of 5. So each one you will solve. For example, if you are choosing 1 out of the 10, which is x1, x2, which means you go back to that equation, put x3, x4, x5 equal to 0, and solve for x1, x2. That is one of the algebraic solutions. Like that, you evaluate all the 10. But if the question is, how many solutions are there? The answer is 10 solutions are there.
There was a doubt on the questions in module 6, 19th and 20th question, which talked about maximization objective function in a transportation problem. The question is how to approach that problem.
Okay, do I also talk about that change in the answer? No.
That has been taken care of.
Very good. So the question is, how do I approach a maximization transportation? The answer is very simple. Solve it like a minimization by putting a minus in the cost coefficients. That is the answer. That is the simplest way to solve a maximization transportation. For example, generally in maximization, you don't use the word cost, you use the word profit. But whatever you use as cost, that number, you are maximizing Cij, Xij in a maximization transportation. In a normal minimization transportation, you are minimizing Cij, Xij. But if you are going to use this northwest corner or Vogel's approximation followed by MODI, then the way to solve a maximization is to put a minus sign and then solve it exactly like a minimization, so that the algorithm does not change. The data is just adjusted to have a negative sign in the cost coefficient. That is the easiest way to do it. But if you want to do Vogel's approximation directly on a maximization, then you have to change the idea and say the penalty is the difference between the maximum and the next maximum, which will complicate the whole thing. Therefore, when you put a minus sign and use the same penalty, which is the minimum, the next minimum minus minimum, with a minus sign, it is exactly the same as maximum minus the next maximum. So rather than change the algorithm, the standard procedure is to change the data, put a minus, and solve it as a minimization problem. And at the end, you will have an answer. Once again, multiply with -1. That will be the maximum value. So I would suggest this idea of taking the costs, whatever you put in that small thing in that corner, those costs, make it minus, and use the algorithm as it is. Nothing will happen. You will get the answer.
There was an earlier question in the forum on why do we not use transportation problem algorithms to solve an assignment problem. There was a student who had posted that I had solved with the same algorithm and got the similar solution. So why do we not approach the problem?
We'll answer that question. Before I answer that question, let me also tell you, at some point I told you to start working problems, take an OR book and do it. So another thing I'm going to tell you is this. There are other videos of mine, which is a course called Fundamentals of Operations Research, which are available on YouTube and so on. In addition to this MOOC course, or the MOOC NPTEL course, was specifically created as an 8-week OR course. So my earlier videos are for a general OR, and they are also available. And if possible, view them. There are 22 videos which cover a wide range of topics. I think up to some sorry about the interruption. So my request is, there are 22 videos in this course called Fundamentals of OR. Each video is roughly about 50 minutes, 50 minutes. I think about 16, 17 videos essentially cover the topics that have been covered in this 8-week course. The only difference is there I would not have done the bin packing formulation. I would have restricted myself only to linear formulations. And there I will not talk about using the Excel sheet and solving problems. So in your own interest, you can view those videos. They are reasonably well viewed, if I may say that. And I have actually answered this question in that video. Now let me give the answer to the question. What happens is, which I have not gone into that depth in this course, there I have given you that depth. There is something called a degenerate LP. I think I would have spoken about degenerate LP in this course. So an LP or a solution is degenerate if a basic variable takes value 0. Similarly, there is a degeneracy in transportation problem. So if you are looking at a transportation problem with m supply points and n demand points, we normally say that the number of basic variables is m plus n minus 1 under the assumption that the problem is balanced, and therefore since total supply is equal to total demand, you get one solution less or one basic variable less. So you will get m plus n minus 1. So if you are solving a 3/2 transportation, then there will be 4 solutions, 4 basic variables in a normal solution. In a degenerate transportation, you will get one less than that. Which means, to give another example, if you are solving a 3/3 transportation, in a non-degenerate transportation, there will be 5 basic variables, m plus n minus 1, 3 plus 3 minus 1, 5 basic variables. But a degenerate transportation will have 4 basic variables. It would still satisfy the supply demand and all of that. Solving degenerate transportation problems, particularly by hand, is a little more time consuming when you start using this Vogel's approximation, MODI method, and so many things have to be done. All that I have explained in the other videos. Now you start looking at the assignment problem. Now the difference between the assignment problem and the transportation problem is this. Number one, assignment problem has an equal number of rows and columns. Transportation need not have that. So assignment is n plus n. So if you look at the assignment problem as a transportation problem, where there are n supplies and n demands, each supply is equal to 1 and each demand is equal to 1, you can look at an assignment problem as a transportation problem that way. But if you look at it as a transportation problem that way and apply the m plus n minus 1 rule, you should have n plus n minus 1. You should have 2n minus 1 basic variables in the solution. But if you see the assignment carefully, assignment will have only n variables in the solution. If you have a n by n matrix, there is one assignment in every row, there is one assignment in every column, and therefore there is a total of n assignments only. So you look at it as a transportation, you should have 2n minus 1 variables basic, which means you should have 2n minus 1 assignments, out of which n assignments take the value 1 and the remaining n minus 1 assignments take a value 0. So assignment viewed as a transportation is a highly degenerate transportation problem. Therefore, the transportation algorithm is not used to solve an assignment problem because of degeneracy and more iterations, and therefore it is not used. Therefore, hand calculation of assignment or faster solution of assignment, the first algorithm that is suggested is the Hungarian algorithm, which I would have explained both in this set as well as in the other video. But if the person who said, I have tried transportation and I have solved it, if you solved it by hand, you would realize that it would take extra iterations. Whereas if you solve it on a computer using Excel, particularly you solve it as using a solver like Excel, you are only going to solve the linear programming version of the problem. Therefore, it doesn't make a difference whether it's LP or whether it's transportation or whether it's assignment. Now you can think of it, it's the same LP formulation that you will be solving. So the real difference comes when you solve it by hand, or the real difference comes when you write your own computer programs to solve this. Then you use the Hungarian algorithm for the assignment, and you will not use the transportation idea to solve the assignment.
Can cost elements in assignment problems be negative?
Just as you have a maximization transportation, you can also have a maximization assignment. There are several examples. For example, let's say I'm a company that has 4 projects, and I want to give those 4 projects to 4 people. So I'm asking for bids, tender or whatever, but I'm asking for a different kind of a bid. So what do I do when I ask for a bid? I give it to the person who bids most money. So I have 4 projects, I invite bids, and each person can bid and give. Therefore, what I will do there is I will give it to the company who is bidding highest to do that. So that can be an assignment problem. For example, I have a case where you can have a situation of, let us say 5 MTech students who have to do their project, and let us say there are 5 guides, and then I want to assign the student to a guide. So I want to give 1 to each guide, and each student goes to only 1 guide. But I ask the guides or the students to give a score for each student. So then I will do the assignment based on maximizing the score. So just as you have a maximization transportation, you can have a maximization assignment. So when you solve the maximization assignment using the Hungarian algorithm is meant to solve a minimization assignment. So the easiest way to solve a maximization assignment is to multiply the cost by -1, solve it as a minimization. Therefore, you will have a situation where the cost in the assignment problem can also be negative, particularly when you solve a maximization assignment problem.
For assignment problem, first, can we subtract a constant from the column and then from the row?
You can do that. There is absolutely, the final solution will not change. You can do the column subtraction first, and then you can do the row subtraction. Unless very specifically stated, if it says do the row first and then do the column, then you have to do the row first. But if you are solving a problem just like that, nothing prevents you from subtracting the column first. In fact, I normally have not done that. I've not done that either in the other video or in this. But there is another way to solve the assignment problem called the auction algorithm. And when you actually start understanding the auction algorithm, somewhere when you try to understand it from a managerial perspective, you realize that you are actually doing the column first and then the row. So there's no difference between them.
In solver, if there is alternate optimum, how does it affect the solution in the solver?
To the best of my knowledge, Excel solver does not even tell you that there is alternate optimum. Therefore, there is no question of it giving you the other corner point. The alternate optimum is a very interesting thing, but before that I should also talk about my own experience with the Excel solvers. So depending on the version of Excel that you have, you might have different pop-up screens coming. The more recent Excel versions will give you the options called simplex LP, gradient nonlinear, and genetic algorithm. So you have to choose simplex LP and proceed. The earlier version, if you have an older version of Excel, then you won't have that pop-up or that option there. So you have to go to options, and then you have to tick on non-negativity, and you have to tick on assume linear model, assume non-negativity, and then you solve the problem. That is about this thing on Excel. Not only Excel, a few other solvers that I have used and you may have used will not even give you an indication that there is alternate optimum. Assuming you are solving a small 2 by 2 problem, so and there is an alternate optimum, which means there are two corner points, and you are not sure which corner point will actually come on display when Excel solves it. But in reality, if you understood linear programming, there are infinite alternate optima. Simplex being a method which only does evaluation of corner point will give you both the corner points if you do it by hand. So the specific answer to the question is, well, you don't even have a way to know that there is alternate optimum. So when you use that solver, whatever you get is the solution. Don't worry about alternate optimum there.
If primal has alternate optimum solution, does the dual also have an alternate optimum?
Generally, if the primal has alternate optimum, the dual is degenerate. You have to understand that a little carefully. I have not stressed on this point so much in this MOOCs course. I have touched upon it not to great detail even in that video. So what happens is when you do duality, you assume first of all that the primal is maximization and the dual is minimization, unless otherwise stated. So primal is maximization. So you do the weak duality theorem and say that every feasible solution to the dual will have an objective function value higher than that of every feasible solution to the primal under the primal maximization assumption. Therefore, we ask a quick question: if the primal is unbounded, what happens to the dual? Because when the primal is unbounded, it can have a solution with objective function equal to infinity. Therefore, you go back quickly and say dual is infeasible. Then you get into this alternate optima degeneracy business. And even in the end of the simplex, I would have explained that the Cj minus Zj is effectively the dual solution at the optimum. So what is alternate optimum? Alternate optimum is a non-basic variable taking 0 at the optimum. So when a non-basic variable takes a 0 at the optimum, which means there's an extra variable that is taking 0 at the optimum, which means a basic variable is taking 0 in the dual, and therefore alternate optima of the primal indicates degeneracy of the dual. And there is also an interesting thing. If you actually assume you're solving a small 2 by 2 problem, if you actually evaluate the other optimum, the alternate optimum, the Cj minus Zj's would remain the same, but the solution would be different and so on. But at times there are enough evidence to tell that this entire primal dual understanding actually suffers a bit when the primal has alternate optimum or when the primal is degenerate. So the moment you get into degeneracy and alternate optimum, particularly the managerial interpretations of the shadow prices and all that, they are not so well defined. So at a first level course like this, let us not worry so much about it. But the quick answer to the question is, if the primal has alternate optimum, the dual is degenerate.
There is one more question on grading assignments. As of now, it has been said that the best 6 out of 8 assignments will be taken. In some modules, there were 2 assignments. Will the average of that be taken?
Maybe we'll do something that benefits you. So there's no point in doing something that's not going to benefit you. I will talk suitably with the TAs and the NPTEL team which is doing that. And we'll try to give you the best deal that we can without compromising on the requirements of the exam and the course. We'll do that. If you want the average, we can take the average. Average is good enough, we can do that. Anything more?
There is no more question.
Then are they looking at something? Okay, is there any other question that somebody has here? I thought I will also do something. Occasionally I get emails from people asking me, can you help me solve this and so on. So sometimes I reply to them. So this is one of those kind of questions where somebody said this is a question that appeared in GATE exam and therefore can you help me or something like that. I found the question interesting, so I thought I'll share it with this group. So can I write it? Audio varum உங்களுக்கு. So this is a transportation problem. I'll do that. I hope you can see whatever I'm writing. So it says there are two supplies with 50 and 40, and there are two demands. It says there are two supplies with 50 and 40. So there is a supply with 50. There is a supply with 40. It says there are two demands. The first person is willing to take from 20 to 40. And the second person is willing to take anything greater than or equal to 20. So the question was how many supply points and how many demand points are there when you make a balanced transportation problem out of this, and what is the total supply or total demand if you make a balanced one out of this. The costs are actually not given. So let us assume some costs. So let's assume the cost is not required. So let's just assume that the unit costs are A, B, C, and D. Now what happens to this is the first supply is 50, the second supply is 40. Now I call this person as D1, demand 1. Now D1 says I want between 20 and 40. Therefore I fix this demand is equal to 20. The minimum that I have to give this person, which is 20. I also define another D1, which is called the extra that I give to this person. And this extra can be 20. Because this person wants 20 to 40. So minimum commitment is 20. The extra this person can take is 20. Now this is D2 person. This person says greater than or equal to 20. So D2, the minimum commitment is 20. And this person says I can take anything that you give more than 20, I can take. So what do? The total supply is 90. The minimum I have to give to the D1 first person is 20. The minimum I have to give to the second person is 20. Therefore, my minimum commitment is 40. And at best, I can give extra 50. And this person called D2 says, I'm okay, whatever you give. Therefore, this becomes 50 here. 50 here. No, I think I'm. So this becomes 50 here. Because all the 50 extra, this person says, I can give. Now I am trying to balance it. Now my total supply is 90 as a balanced transportation problem. My total supply is 90, but my total demand is 20 plus 20 plus 20, 60 plus 50, 110. 20 plus 20 plus 20, 60 plus 50, 110. And therefore I have to add a 20 to make this balance 110. So now it has 3 supply points. It has 4 demand points with total 110. But I have to do the costs. So supply 1 to demand 1 is A. Supply 1 to the extra demand 1 is also A. This is B. This is B. But remember that I am committed to giving this 20. So this 20 has to be given out of the available 50 plus 40, 90. And that this 20 should not be given from the other 20. So to do that, or to prevent this any of this 20 from getting from this 20, I put a big M. Now this 20 is not mandatory. So this can be given from this or from the dummy. Therefore, this will get a 0. Oh, I'm sorry. This is first one to this. So A, first one to the first one is A. First one to the first one is A. First one, just give me a minute. First one to the first one is A. So this has to be C. Sorry. So this has to be C. Second supply to first demand is C. So C. So this therefore becomes B and D, B and B. So this becomes B and B. This becomes D and D. This becomes M and 0, because again I have to make sure that this 20 is met from the available 90 and not from the other 20. So this completes the formulation with 3 supply points, 4 demand points, costs redefined, and a total of 110. So these kind of questions are also there, but I have not explicitly done this for you. So there is no reason for me to test you on this. This is more for learning, and at the moment it is not directly related, because I won't see a question from an exam point of view. So I'm going to see this question more from a learning point of view. So somebody asked me how to do this, and this was a gate question some time ago. So I'm just doing it for the benefit of everybody, that this is how you solve a problem like this. Is there any other thing that has come? Is there any other thing that you have? Please write it. I'll be happy to answer them. We'll wait for a couple of minutes. Otherwise, we can wind up.
8 people.
8 people. No reactions. Okay, so I'll assume that all of you have had your doubts and questions cleared. So let's wind up this discussion. So again, let me thank our NPTEL team for arranging this. Karthik has been very, very helpful. Let me also thank Srinivasan, our TA, who has patiently compiled and read all the questions on your behalf. Let me also thank my other couple of students who are sitting here listening to what is happening. Let me also thank each one of you for participating. And I hope that this session was fruitful and your questions were well answered. Thank you very much. Have a good day.